So we are on the 8th section of Unit 4, which is going to be on evaluating sequences. It's going to combine what we've been doing with tables into what we were doing over the last section with these sequences. So just to jump in right away, we're going to be given a sequence like something at the top. We used to see this as f of x is equal to 3 and then an x in the middle. It's very similar now, except we now have n's here. And if you wanted to change those all to x's, that would be fine. It's no difference. But what we do for each of these is we simply take this number and we plug it in to there, and we figure out what the sequence equals, and then we see the pattern. So for this one down here, if my pen works, there we go. We're going to do 3 times 2 raised to the first. Now, order of operations says we do exponents first. So we do 2 to the first, which is 2. So 3 times 2 is 6. N to the 2, we put the 2 up there. We get 3, parentheses 2, raised to the 2. Do exponents first, that's 4. 3 times 4, that's 12. Yeah, that's right. And then the n is the 3 here. We do 3 times 2 raised to the third. 2 times 2 times 2 is 8. So this is 24. And now we've created our pattern just like we would have created our table before. If you wanted to make this as a table, there's nothing wrong with that. Now, I do make it as a table for this problem just to show you a little difference, but the problem itself stays the same. We take this number, and we're going to plug it in right there. So 2 parentheses 1 raised to the 2. Order of operations says exponents first. 1 squared is 1. So 2 times 1 is 2. Now we're going to put the 2 in there. We get 2 parentheses 2 squared. We do this first, which is 4. So we get 8. Then we do the 3 here. So that's 9, which is 18. And finally the 4th, we're going to do 2. That's 16. It's 32. So all we're doing is creating a table from a more difficult type of function. Okay, remember here, f of n could be the same thing as y, although that's more common if this is x. But it's not really something you need to pay attention to regardless. If we have a function like this, which looks exactly like what we used to do, all we do here is we put the 1 in for the x, the 2 in for the x, and so on and so forth. So we get 3, 1 minus 4. Well, that's 3 minus 4 is negative 1. Put in the 2. 3 times 2 is 6. 6 minus 4 is a positive 2. 3 times 3 is 9. 9 minus 4 is a positive 5. Three times 4 is 12. 12 minus 4 is a positive 8. And if we look, we can see that pattern that we've been creating over the last couple sections, in this case, which we're adding 3. Okay, so this isn't anything new. It's just presented in a different way. Would like you to try this on your own, and then I'll fill it out. So for each of these, this is 1 cubed, which is 1. 2 cubed, which is 8. 3 cubed is 27. 4 cubed, which is 64. If you have questions on this, how to create these patterns, how to fill in the tables, anything like that, make sure you ask me. Otherwise than that, I think you guys should be able to cruise right through this.